Welcome back, I am Jim, and let's go to see the first of the two counting principles, the rule of product. Let's see the theory at first. The rule of product says that if we have a procedure that can be broken down to a sequence of two tasks, A and B, where task A can be done in n ways and task B can be done in m ways, for each way that the first task is done, and this is important, then there are n times m ways to do the procedure. Now let's see what this actually means. Let's say that we are solving an exercise and we observe that in the solutions that we are writing down, these solutions consists of two parts. Let's say part A and part B. Actually here we have splitted the initial problem into two sub-problems, and then we are focusing in each sub-problem separately. We go to problem A and we think how many ways are there for task A to be done. And let's say these are 8 ways. Then, and this is important, for each of these ways for the first task, the second task must be done in the same number of ways. If this applies, then we are counting these ways for part B, and we write down these ways, and then by the rule of product, the total ways are their product. 8 times 5 equals 40 ways. Let's see the examples. He says to me how many binary strings are there. Binary is the same as bit we saw earlier, so I understand that its position may be filled either by 0 or by 1. And then he says of length 3, so I understand that there are 3 positions I have to fill. And then he says that they should start with 1. Let's solve it by hand at first. 1 should be the first digit, and then the other 2 may be any combination of 0 and 1. So it is 0, 0, 0, 1, 1, 0, and 1, 1. And the first place must be fixed as 1, so there are 4 solutions. Let's see now how we can do this by the rule of product. I have 3 dashes, and I observe that the first dash may be filled by 1 and only 1, so there's 1 way to fill it. The second dash may be filled by 0 or 1, so there are 2 ways to fill it. And the third dash may be filled by 0 or 1, so there are also 2 ways to fill it. By the rule of product, we have 1 times 2 times 2, so the overall result is there are 4 ways to do it. When we apply the rule of product, it's usual not to mention things that are done with one way, because we multiply one by the other thing, so the result is the other thing. That's why you see here in the solution that we write that we ignore the first position, there's just one way to fill it, and then we write down that we have 2 ways for each of them, and then by applying the rule of product, there are 4 strings overall. Another thing we should do when we use the rule of product is to confirm the rules of thumb. We have to think that here I'm fixing 2 places, and in the final solution, both these things are done. Indeed, in a final solution, both the second position and the third position must be filled, both of them, A and B. And also, when I'm fixing a position here, I said that I had 2 ways. Then, for each filling, when I filled with 0, there are 2 ways to fill the third place. And when I fixed it with 1, there are 2 ways to fill the third place. So, the rules of thumb are confirming my result. We have already seen that we can apply the rule of product to more than 2 tasks, but this is called the generalized rule of product. Let's see the example to understand it better. In the local PC store, there are 12 keyboards, 4 mice, and 12 screens. How many ways are there to buy one of each? So I understand that I am fixing 3 positions. The first position is about the keyboard, the second is about the mouse, and the third is about the screen. And the first position can be filled with 12 ways. There are 12 keyboards. The second can be filled with 4 ways, there are 4 mice, and the third can be filled with 2 ways, there are 2 screens. So the overall result comes from the generalized rule of product. We write simply by the rule of product, and the result is 12 times 4 times 2. There are 96 ways to take one of each of these things. I confirm again that the rules of thumb applies here. The task may be split into 3 consecutive tasks When I choose a keyboard, it does not change the ways that I choose a mouse or a screen, so I have no problem with that. And in the final solution, all the three things must be chosen: the keyboard, the mouse, the screen. And our final example, your school offers 3 math, 2 physics, and 2 chemistry classes this year. You're going to pick one of each. How many picks are there? So I have to pick 3 things. I have 3 positions to fill. The first position is about math, the second position is about physics, and the third is about chemistry. I go to the first position and I see that there are 3 ways to fill it. 3 ways. 2 ways about physics and 2 ways about chemistry. The rules of thumb apply. All these 3 things must be chosen. And also, when I'm choosing a math lesson, the ways to choose a physics and a chemistry class remains the same. So I have confirmed that the rules of thumb apply and my result is correct. Again, the theory was just that we can multiply 2 things, but we have to know very good that we can multiply if the rules of thumb apply. So the exercises are there for you.